Ms. Garcia, it's Sophie Gutierrez, and this is my concept map video final. So I'm going to be covering linear, parabola, and systems of equations. So let's begin. Functions, the relation between every input and output. Each input has one output. We're going to be going over linear, which is y equals x, and parabola, which is y equals x squared. So a linear function, the y is the dependent, x is the independent. Slope controls the steepness of the line. The greater the slope, the steeper the line is. So 9x is a lot steeper than 2x. This is the symbol delta, delta y over delta x. Delta is the change in quantity or position, which means the change in y over the change in x. And we use slope triangles to find the slope. So the change was 4 over 4, which is the same as 1, or m, rise over run, growth over change. And to find slope in the y-intercept using a graph, we used slope triangles or delta y over delta x to solve for m. And the point on the y-axis where the line crosses is the y-intercept, same as b. And to find m using a table, you use delta y over delta x. And to find b, you look for the ordered pair where x equals 0. So there are 4 different types. Positive slope increases towards the right. Negative slope increases towards the left. Also, the a is negative. Zero slope, completely horizontal, and undefined is completely vertical. So there are 3 different forms. Standard form, which is ax plus by equals c. Slope-intercept form, which is y equals mx plus b. It's the most common. And point slope form, which is y minus y1 equals m times x minus x1. Point slope form is used when you only have the slope and one coordinate point. Slope-intercept form is used when you have only the slope and the y-intercept. And slope-intercept form equation looks like y equals 3x plus 2. And point slope form equation looks like y minus 5 equals 3 times x minus 1, and a standard form equation looks like negative 3x plus y equals 2. So now we're going to be going to parabolas. Parabola is the graph of a quadratic function, and the quadratic formula is ax squared plus bx plus c when a doesn't equal 0. So it has an axis of symmetry. That's the vertical line that passes through the vertex and divides the parabola in half. All parabolas are symmetrical. To find the axis of symmetry, we use b over 2. So if we have the equation y equals x squared minus 16, where b is 0, we substitute that in, and we find that the vertex is 0, negative 16. So to move the parabola around, increase bx, move left on x, decrease bx, move right on x, decrease c, move down the y, and increase c, move up along the y-axis. We also know that standard form, the numbers can be substituted into a, b, and c. Factored form looks like y equals x minus x1 times x minus x2, and we will be using the zero product property, so we set it equal to 0. X plus 2 equals 0, and x plus 3 equals 0 to get our roots x equals negative 2 and x equals negative 3. And an example, when we have it in factored form, we distribute and combine the like terms to get the equation x squared plus 5x plus 6, for example. And the sum in standard form, as can be seen with this algebra tile, we get the sides to get the factored form, we organize it by the highest power, and the area in product form, which is the side lengths, is x plus 4 times y plus x plus 2. So there are a couple ways we can solve for a parabola. We can use the generic rectangle, where we're just trying to find the common factor to multiply and get the numbers on the inside. We can use completing the square, where we have to solve for 2 different ones. So if we get down to x equals negative 4 plus or minus the square root of 3, we have to do one that is plus the square root of 3 and minus the square root of 3. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So we substitute the numbers in. I was solving for x squared plus 3x minus 4 equals 0. And I found the roots negative 4, 0, and 1, 0. So these are the different kinds of parabolas. So if anything under the radical, it's called the discriminant. If it's less than 0, there are no real roots. If it's equal to 0, they're real and equal, and if it is greater than 0, the roots are real but unequal. So now we're going to move on to systems of equations. It's a set of more than one equation that is graphed at the same time. And the solution is the point of intersection for both lines. If they cross one point, then they have one solution. Parallel lines, such as seen here, have no solution. If the lines overlap, then it has infinite solutions. Perpendicular lines have one solution, and the second slope is the opposite reciprocal of the first. So example here. And an example equation would be y equals 3x plus 2. It's the same, its reciprocal is y equals negative 1/3 x plus 2. To solve for it, you can use substitution method. One equation needs to be in slope-intercept form, so you can substitute the defined variable into the equation. Equal value method. Both equations need to be in slope-intercept form, and you can set them equal to each other. Or elimination method, where either add or subtract the equations to get one equation with one variable. You place one equation on top of the other and solve for one of the variables. So real-life equations now. So when do we use the elimination method in real life? For example, when you're choosing which store to buy your shirts from. So you have Harper's versus Iced T-shirts. They're the same, but the prices are different. So Harper's, say, is y equals 21x. Iced T-shirts is y equals 18x plus 15. That means that at Harper's, a shirt costs $21, and at Iced T-shirts it costs $18, but the startup price for printing on it is $15. So when graphed, they both sell 15 shirts for $315. That's the solution, is 15,315. So if you want to buy 15 shirts, you can buy them from either, and if you want less than 15 shirts, you should buy from Harper's. And if you want more than 15 shirts, you should buy from Iced T-shirts, because as you can see, they switch. Harper's is cheaper before you reach 15, and Iced Tea is cheaper after you reach 15. And how do we know? Because we use the elimination method, as you can see here, where you just set one on top of the other and subtract, or add. In this case, we subtracted, and we get the coordinate 15, 3, 15. And when do we use parabolas or quadratics in real life? Parabolas and quadratics, this is what they look like, negative and a positive. So roller coasters is where they show up. The vertex would be the highest point that you reach, and the roots are when the cart comes back at ground level. Or in sports, where x equals the time, y equals the height. When it's graphed, as you can see, a ball being thrown in the air forms the shape of a parabola. So, Ms. Garcia, these are my attempts at reasoning questions. The first would be, when would we be able to apply the Pythagorean theorem in real life? The second, why use absolute value if you could simply switch the sign? If it means that the number inside of it is positive, why not just use a positive number in the first place? And the last question, why were so many methods and forms created if they yield the same result, such as the generic rectangle, completing the square, and quadratic formula? Or, when I'm talking about forms, the standard form, slope-intercept, and point-slope form, if it's basically all the same thing. So this has been my concept map final, and I hope you enjoyed.